Okay, well, welcome back. We are jumping into chapter 3 today. In chapter 3, we're going to spend just a brief little time, just 2 sections. We'll do 1.5 of them today, and we'll finish up the other, and then we'll do a little bit of chapter 4 we're going to do, and that'll complete this unit. So in section 3.1, we're going to talk about this mathematical object called a system of equations. So the new thing here is the idea of what's called a system. So just to show you and explain to you what a system of equations is, I'm going to write an example of one on the board. A system of equations looks like this. I'll have a first linear equation, x plus y is equal to 6. And then I will have a second one, which will be 4x minus y is equal to 14. So what's happening here is I am given 2 equations, and we're going to consider them together. Okay, so the system of equations, in this case, they are linear equations. When you get to other classes, if your math destiny takes you to college algebra and pre-calculus, you'll talk about systems of equations that involve other equations, not just linear ones. So we need to talk about how to treat these. We're going to talk about how to solve those. So the first thing is, what does it mean if I say something is a solution to the system? Okay, so a solution to a system of linear equations is going to be an ordered pair that satisfies both equations. So a solution is an ordered pair that satisfies both equations. I'm going to underline the word both. If you don't understand what I mean by the word satisfy, what I mean is it creates a true statement. When I put the ordered pair in, it is good. So the first thing that we're going to do today in our hope to develop some experience using systems of equations is we are going to determine if I give you an ordered pair, is that ordered pair a solution, yes or no? So here's the first question we're going to ask, and it is this: of this system right here, is the ordered pair 4, 2 a solution? Okay, this pen is not with us anymore. So I want to know, is 4, 2 a solution to this system? And I just want to reiterate, because this is the big deal, it has to work for both equations. It can't just work for one. Okay, it has to work for both. So we're going to check. And so the arithmetic hopefully isn't too big of a deal. If you have any questions about where I got a number or why I'm putting a number in a particular place, let me know. So the first equation is x plus y equals 6. So the x value is 4, the y value is 2. Is that a true statement? Is 4 plus 2 equals 6? So far, so good. But before I can answer this question, I am not ready yet. Okay, it has to work for both. So now I got to do the second one. So 4x minus y is equal to 14. So again, x is 4. 4 times 4 is 16. Minus y is 2, is equal to 14. Is that a true statement? Is 16 minus 2 14? Yes. And so the answer to this question is 4, 2 a solution. The answer to that is yes. It indeed satisfies both equations, and that is what it means to be a solution. We good with the idea of what a solution is? I'm going to give you a problem like this. You're going to do the exact same thing just to make sure that you're doing the writing. But if you have a question, let me know. I'm going to change the system. This is going to be your system. It's going to be 2x plus y is equal to -6. That's the first equation of the system. And then x plus 3y equals 2. And so the first point we're going to determine if it's a solution or not is 3, -12 a solution to this system? Is 3, -12 a solution? So I'll give you 90 seconds or so to do that arithmetic and determine your answer. All right, I'm going to start with the arithmetic. If you're still working, keep working. We should come to the same conclusion. Let me know if you have a question. I'm going to start with the top equation. So 2x plus y is -6. The x value is 3. So 3 times the 2 is 6. The y value is -12. Is 6 plus -12 equal -6? Is that a true statement? Yes. Okay. Again, don't skip. Make sure it works for both. So x plus 3y equals 2. So the x value is 3. 3 times the y value, 3 times -12 is -36. Is 3 plus -36 equal to 2? No. 3 plus -36 is -33. So that one is not a true statement. It's false. So the question is 3 comma -12 a solution? The answer to that is no. So just one more, just so that I feel good, like I'm doing my job, earning my money today as an instructor. So you're going to do it one more time. Is -4, 2 a solution to that system? So once again, I'm just going to get started with this arithmetic. The top equation is 2x plus y is equal to -6. So 2 times the x, 2 times -4 is -8. The y value is 2, and -8 plus 2 is indeed equal to -6. So we're 1 for 1, but we've got to test both. So x plus 3y is 2. So the x value is -4. 3 times the y value, 3 times 2 is 6. Once again, -4 plus 6 is 2. So this one is -4, 2 a solution, and the answer is yes. So before I move on, I don't want to be in a rush. I want to make sure that any questions you have are adequately answered. Are we up to speed on what it means for something to be a solution? Now, that's not very fun. I think we'd all agree. It'd be more fun to be able to find a solution. So that's what we're going to do next. So what I want to do first is, and I'm assuming some people in here have seen it, but I'm treating it like you haven't. So bear with me if you're a little bored because you've done this before. We're going to now look visually at what it means to be a solution. What are we saying when a point satisfies both of these equations? So I'm going to come over here. I gave everybody a piece of graph paper on the way in. If you're watching the video, print a piece for yourself. Let's see. Hang on. Why isn't this responding to me? There we go. Thank you, slow computer. Okay. So here's what we're going to do. We are going to take this system of linear equations and we are going to graph them. So here is the system that we are going to work with. It is this. We are going to have 2x plus y is equal to -5. And then we're going to have -x plus 3y is equal to 6. So that's my system of equations. Okay, that we're going to endeavor to learn how to solve these. So this is our first effort. You could be asked to solve a system by graphing. In fact, on the test you have next week, I will ask you to solve one by graphing, just because we're continuing to review graphing. So here's what you're going to do for me. I'm going to give you a couple minutes. I want you on the same Cartesian plane. I want you to graph both of these lines. I'm going to graph by finding the slope and the y-intercept, but you can use the x and y-intercept if you want. You can plug in points if you want, but let's graph both of these, then we can talk about what the solution is. Okay, so get started.
I do not. Yeah, I'm sorry, I did not. Just cracking both those lines.
All right, help me in this review. There is going to be graphing of lines on the next test. It's all part of something that goes between both of Unit 1 and Unit 2. So if I want to solve this equation, I've rewritten right here for y, what am I going to do first? I'm going to put it in slope-intercept form, and to do that, what do I do to both sides? Yep, I'm going to subtract the 2x. In fact, that's the only step on this one, is to subtract the 2x. So I get y is equal to negative 2x minus 5. And then that tells me that the slope is equal to negative 2, which I'm going to write as negative 2 over 1. So I have both my rise and my run. And then the y-intercept of this graph is, boom, yes, negative 5. Thank you very much. So if you put the negative with the 2, remember that means your y direction is negative 2, your x direction is positive 1. But you could always put the negative with the denominator if you want and have positive 2 in the x direction and negative 1 in the positive 2 in the y direction and negative 1 in the x direction. Either way, whatever makes you happy. So my y-intercept is negative 5. If I put the negative with the 2, that's down 2 and positive 1, down 2, positive 1. If you did the other thing, that is positive 2, negative 1, positive 2, negative 1, and positive 2. I'm just having a great time doing that. We'll now connect the dots. Okay, so we talked about graphing lines. It was on the last test. If you are struggling still to graph lines, please let's talk. Get you where you need to be. It's not going to go away. It's going to be on the final exam. And I want you to do great when we get to that point. All right, the next one, I'm going to do the first step. I'm going to add the x to both sides because I'm going to do the same thing. I'm going to solve it for y. And so I get 3y is equal to x plus 6, or 6 plus x if you prefer. And when I divide by 3, remind me, on the right side of this, what do I have to remember to do with the 3? I have to divide it. Do I just divide it into the 6? No, you have to do it in the both terms, the distributive property. We're used to distributing with multiplication. It also applies in this situation. So since I have a 1 in front of the x now, that's going to be a 1 over 3x. And then the 6 over 3 becomes 2. So my slope of this line is 1 over 3. So 1 in the y, 3 in the x. My y-intercept is 0, 2. And let's graph. So 0, 2. 1 in the y, 3 in the x, 1 in the y, 3 in the x. Well, we can go backwards if we want, but I'm just going to connect the dots. Oh, beautiful. Line of the year. Okay, so the reason we did this, we're only going to do one to solve by graphing because I just wanted you to see in a picture of what we've already done before, what it means to solve a system. When I told you earlier, you have it written in your notes, a solution to a system is an ordered pair that works in both equations. So if it's an ordered pair that works in both equations, where am I going to look on this picture? How would you describe the solution to that system? It's where they intersect. It's where they cross over. Okay, so right here, this point right here, that's the solution. So if you ever solve for by graphing, you're just going to graph the two lines, and then you're going to count. That means I went 1, 2, -3 in the x direction, and then +1 in the y direction, and that is my solution to the system of equations. It's the point -3, 1. So we're gonna turn to the algebra way to do this, because graphing's lovely when your solution is going to fit on your page, or when the solution is going to be integers. But what happens if you're going to get decimals or fractions? So we need an algebra way to do it. But I just, again, wanted you to see, in case you haven't before, what it means.
The solution. We are finding where two lines intersect. So now, there's two algebra ways to do this. I'm going to show you both. I'm going to give you advice on when to use each. The first way we are going to solve is we are going to solve a system by what's called the substitution method, which kind of tells you what you're going to do. Here's an example that's going to work really well with the substitution method. It says this: 2x minus y is equal to 6. And then x equals y plus 2. These are my two linear equations. And we're going to solve by what's called substitution. And so the first question on your mind, I'm sure, is something students have asked before. Hey, Perkster, how do I know? How would I know to use substitution versus the other way you're going to show me in a little while? That is a phenomenal question. Well, first, substitution will always work. Okay, so if you choose to use it, it's going to be great. But there's good times and bad times to use substitution. So I just want to give you a little advice. A good time to use substitution is when one of the equations has a variable that is simple to solve for. Remember, simple doesn't always mean easy. I'll show you this on your second example, but what I mean by this is we want to avoid fractions. We want to avoid a lot of steps. We want to use substitution when we can identify that there's one variable that is super easy to go ahead and solve for. Now, on the example I've given you that we're going to do together, one of the equations is already solved. So that's a great time to use substitution, is when something's already solved for the variable. Once we have it like this, here's how we're going to do this. This second equation, it tells me wherever I see an x, x is equal to, it's the same thing as, x is the same thing as y plus 2. So what I'm going to do is I'm going to take this x equals y plus 2, and I'm going to substitute it. I'm going to plug it in to the other equation. So I'm going to take this x and I'm going to plug it in right here. All right, let's do that. I told you when we talked about functions, the way I like to substitute is I like to do this. I've got 2 times x. So I'm where my x is, I'm going to leave a little space for whatever I'm plugging in. So 2 times x minus y equals 6. And what am I going to plug into the parentheses according to the second equation? Y plus 2. Yeah, y plus 2. At this point, I'm going to tell you the same thing I told my class yesterday. That's the hard step. That's the new thing. Okay, we substituted. At this point, this is stuff we've been doing since the first day we've been together. We're going to solve this equation. If solving an equation is difficult for you, okay, if you still are not catching on to this, we need to talk. Please don't be scared to talk to me. Let's get you what you need, okay? Because solving equations is not going to go away for the whole rest of the semester. Okay, so if you look at this and you're intimidated and you have no idea where to start, we need to talk. We need to have a conversation after class. So what I'm going to do is the same steps we've been doing since the first day of class. I'm going to distribute. Okay, so you can write this down. Okay, if you need to distribute, collect like terms, solve. Okay, 3 steps. 2y plus 4 minus y equals 6. That's the distributing step. Here's the collecting like terms. 2y minus y is 1y. And this equation only has one step to actually solve, that's to subtract the 4, and I get y is equal to 2. Well, we've done 90% of the work, but we've got half the answer. Half the answer is y equals 2, but as we saw in our drawing, the answer is an ordered pair, or will always be an ordered pair. So what am I going to do with this y equals 2 in order to figure out what the other part is? Yeah, you can pick either equation. Okay, there's no wrong answer here. You'll get the same thing, but I like to be lazy. So I'm going to use this equation because it's already solved. So I'm going to take the x is equal to y plus 2, and I'm going to take this value and plug it in for y. So we get x is equal to 2 plus 2, and 2 plus 2 is 4. And so that's our solution. Our solution, and we're going to write it as a point, since it is a point. The x value is 4, the y value is 2, and we're just going to throw some squigglies around it so that we don't accidentally think that's interval notation. Okay, so this is our solution set. It's the point 4, 2. I'm going to give you a problem that's just like this. But before I do, does anyone have any question, comment, concern? Yes. I think my math app already puts those in for you. I'm kind of leaning about it on the test. In college algebra, I'm a lot more strict about notation than I am in this class. So if you can develop some good habits now, that'll help you then. So again, just to repeat, what these squigglies are telling us is that that's a point. It's a set with a point in it. If I don't have the squigglies, then I might think, oh, that's the interval, right? Because we use parentheses for intervals. Okay, so that's the reason for it. It's not just because I have something else I want you to do. So yeah, great question. Anything else? All right, here's yours. I'm going to give you 2 examples to substitute. The first one is going to be very similar to mine. It's 5x minus 3y equals -6. That's the first equation. And then x is equal to 2 minus y. So solve that system, come up with the ordered pair. I'm going to give you 2.5 minutes to roll through that. All right, so once again, I'm going to perform the substitution. This first problem I've given you is already set up so that you would use substitution. I know that because this second equation is already solved for a variable, so why do more work than I would have to do? So I'm going to take this value of x and I'm going to plug it into the equation right above it. So that means I have 5 times my x value minus 3y is equal to -6. My x value is 2 minus y. And I'm just going to pause here. This is the new bit. Okay, this is the substitution. Are we okay? If you're not, be honest with me. Let's get this out in the open. All right, yesterday I had some struggles in my other class. I didn't have enough caffeine apparently. So check me here. 5 times 2 is 10. 5 times -y is -5y. Minus 3y is -6. I'm going to collect those like terms. -5 and -3 is -8y. Subtract the 10. Again, I'm just rolling through this solving because I'm assuming we all feel pretty good about it. If that is not you, if you don't feel good about it, we need to talk, okay? And I want to talk. So my y value is 2. Anybody get something different and you don't see why? Maybe you made a little mistake. I understand sign mistakes are easy to make. Forgetting to distribute all the way, it's easy to do. All right, one more time. I'm going to take this y equals 2. I'm going to come up here. X is equal to 2 minus y. And so x is equal to 2 minus 2 because I just put the y value in. X is 0. 0 is okay. It's a value. So here's my ordered pair. 0, 2. To revisit the question that was asked just a moment ago, while on the test, I will be fairly lenient about the squigglies. If you don't write it as an ordered pair, there will be a deduction. Okay, I want you to understand. You're telling me that you know that the solution is a point. Okay, when you do that. All right, here's another problem. So let's do this, or you're going to do this for me. 4x plus y equals 5. And the second equation is 2x minus 3y is 13. After you write, I've got one quick question before you roll into this problem. So write it down, and then okay. So I told you that substitution is a great method to use when one of the variables is super simple and easy to solve for. So on here, there is one variable above all the others that is super simple and easy to solve for. Which one is it? The what? Top what? Which one? Is the x or the y at the top? Which one's easier to solve for? Ooh, she's right. The y. The reason it's the easier one to solve for is there's no dividing. It's just one step. So look for that. I mean, you could solve this one for y, but then you're going to have fractions and it's going to be gross. And why would you want to go through all that work? Okay, so my recommendation is when you use substitution, use it when you have a variable that looks like, okay, let's try again. Looks like, there we go, looks like that, where it has no coefficient. It's just a plain old variable, so it's one step to solve for. So that's what I'm going to do in just a minute. I'm going to give you a couple minutes to solve. First thing you're going to do is solve this one for y, and then it's going to become just like the previous two problems we've done. Well, I'm going to reaffirm, you can use substitution anytime, but it's best to use, or the easiest to use, when there's a variable by itself. Yes. All right, so let's get started on this. So if I have the 4x plus y equals 5, we've done this dozens and dozens of times in here. If I'm solving that for y, all I'm going to do is bring this 4x over. I'm going to subtract it. It's just what we did earlier when we graphed and we were putting it in slope-intercept form. So that's going to give me y is equal to negative 4x plus 5, or 5 minus 4x if you prefer that order. And now I'm going to take this and I'm going to substitute it into the y right here. So this equation right here now becomes 2x. minus 3 times my value of y is equal to 13. And the value of y that I'm plugging in is negative 4x plus 5. So negative 3 times negative 4x is plus 12x. Negative 3 times positive 5 is negative 15. I'm going to combine these like terms. 2x and 12 gives me 14 of them. I'm going to add the 15 to both sides. And we get 14x is equal to 28. And then finally divide. Okay, again, I just rolled through the solving. I'm assuming that we're getting okay and adequate at that. Anybody got a question about any of my steps? Something not making sense to you? All right, then again, you can take x equals 2. You can plug it in here. You can plug it in here. But I'm going to plug it into the equation that I've already set equal to y so that it's just a little less work for me. I've already put some effort into that equation. So I'm going to take the x equals 2 and I'm going to put it here. So we're going to y is equal to negative 4 times 2 plus 5. Negative 4 times 2 is negative 8. So that makes my y value negative 3. So my x is 2, my y is negative 3. There's my solution. If we were to graph those lines, that's exactly where they would intersect. That's the substitution method. The next method, the other method, actually my preferred method. You can use either of these methods anytime. Well, that's kind of smearing rather than erasing. Thank you. Appreciate that. The belt sander to erase these markers today. Okay, so the next thing is we're going to solve the next couple by what's called elimination. Elimination sounds much tougher and more violent than substitution. So here's the first system that we each solved this way is going to be set up in such a way just to show you the principle behind elimination. And then we're going to each do one that is a little more difficult and would be the most difficult style of problem. So here it is, 2x plus 3y is negative 6. And then the second equation is 4x minus 3y is equal to positive 6. I'll give you a moment to write those down. So if you've done this before, you see exactly why I've picked these two equations. The premise to elimination is this. I've got two equations. I know when things are equal, I can just combine them and I still get something that's equal. So if I'm just going to go through and add everything up, if I'm going to add the x's, I'm going to add the y's, I'm going to add what's on the other side, what happens to my y terms when I just add them up? They're going to cancel. That's the principle, that's the premise behind the elimination method. You want to get your two equations so that when you add the variables up, either the x's or the y's is just going to cancel right out. So this one I've set up in that way just to be like nice one-step problem. Let's add them up. 2x plus 4x, that's 6x. 3y minus 3y, those cancel. That's great. That's what I wanted. My equal sign, just drop it down. And then on the other side, negative 6 plus 6, that is 0. That's okay. 0 is a number. And then once you've done that, the second step is just to divide. And if you have 0 of something and you divide it into 6 parts, each part is 0. So there we go. There's my first half of the answer. The x is 0. Any thoughts on what I should do with this in order to figure out the other value? Plug it in for y in either, or plug it in for x in either one of these. It absolutely does not matter. Okay. If you want to test me and see, you pick the opposite equation. I'm just going to use the top equation because it's on top. I have no secrets here. I'm not withholding anything from you. So x is 0. So 2 times 0 plus 3y is equal to negative 6. So that leaves me 3y is negative 6, and I divide by 3, and the y is negative 2. There's my other value. So the x is 0, the y is negative 2. There's my squigglies. That's the elimination method. All right, here's an elimination for you. Again, I'm going to set this first one up so that there's not a whole lot to do, just so that you can see how this works in general. So your system is this: 8x minus 2y is equal to 5, and then the other one is 5x plus 2y is equal to negative 18. So solve that by elimination, please. All right, so here goes. First step is to just observe, okay, I've got a negative 2y here, I've got a plus 2y, so they're going to eliminate straight away, which is what I wanted, why I gave the problem. So let's just add them up. 8x and 5x is 13x. The negative 2y plus the 2y cancels. And then 5 minus 18 is negative 13. We good so far? Anybody not know where to start this problem? So now I'll divide by 13, and I get x is negative 1. So there's my first part of the solution, my first part of the ordered pair. Take the negative 1, pick an equation. We will get the same y value, whatever one you pick. I'm just going to use the top one. So 8 times x is 8 times negative 1, minus 2y is equal to 5. 8 times negative 1, negative 8. I'm going to add 8 to both sides. And then divide by the negative 2. And we got a fractional answer, and it was almost painless. Didn't even have to deal with the fraction at all. Okay, so my x value is negative 1, my y value is negative 13 over 2. There's my ordered pair, and I'm done with that problem. So I've got one more for each of us that's going to demonstrate basically as hard of a problem as it could possibly be. But before I move on, any questions about the principle of elimination? Okay, so over here, I've got 5x minus 2y is equal to 4, and 2x plus 3y is 13. And here's what we observe. Substitution is not a great method to use here because there's no variable that's going to be nice and quick and clean to solve for. If I add everything together, does anything just cancel out right away? No. Okay, so what we have to do first, before that, is we need to set this equation up so that either the x's or the y's have opposite coefficients. So here's a question I'm going to ask you. There is no right or wrong answer to this question. This is purely preference. Do you want to eliminate the x's or eliminate the y's? Okay, I heard y's first. Okay, so that's why I'm going with it. It's no harder to do the x's. Okay, it's the same amount of work. Okay, so that's just purely a preference question if you're wondering why. But I heard y's. Okay, So here we go. We're going to eliminate the y's. I've got a -2 in front of this y. I've got a +3 in front of this one. What's a multiple that 2 and 3 have in common? 6. Now, again, I'll tell you the same secret I told you when we talked about fractions. You can use any common denominator you want to, but the lowest one will keep the numbers more manageable. So 6. So if I'm going to get the same coefficient but opposite in front of these two things, what am I going to multiply the top equation by? Okay, 3, because 3 times -2 is going to be -6. What am I going to multiply the bottom equation by? 2, because 2 times 3 is +6. Just going to call timeout. Let's say the majority opinion was let's eliminate the x's. Okay. 5 and 2, common multiple is 10. What would I have to multiply the top one by? Yeah, you'd have to multiply one of them would have to be negative. Okay, because these are both positive numbers. So you would have to do like -2 in the top to get a -10 and a +5 or vice versa. +2 and -5. The reason we did not have to do one by a negative here is because the negative was already there. You with me on that? The next one will hopefully we'll be able to apply that. All right, so here we go. 3 times 5, 15x. 3 times -2, -6y. 3 times 4 is 12. Bottom equation, 2 times 2 is 4x. 2 times 3 is +6y. We accomplished our goal. We have the same coefficient, just opposite in front of both of the y's. And 2 times 13 is 26. Gonna add them up? Yeah.
So you just found the common
Multiple?
of the 2 and 3.
Yep, that's it. And sometimes it's just going to be what you get when you multiply them together. Other times there's a lower number you could get. But again, if you used 12 here and it's going to work. Okay, so don't put great stress on yourself in that regard. All right, 15 and 4, that's 19. The 6 y's cancel. That's good news. 12 and 26 is 38. And when I divide, the x value is 2. And then once again, it does not matter which of the equations you pick to figure out what the other value is. Again, I'm just going to use the top equation because it leaves me a little extra room. So I have 5 times 2 minus 2y is equal to 4. 5 times 2 is 10. Subtract the 10 from both sides, and I get -2y is equal to -6. And at long last, we're done with the problem. Y is equal to 3. If you can sort through this problem, the problem's getting no harder than this. Okay, we've done everything possible. We've had to manipulate the coefficients, we've eliminated, and then we've figured out the other values. We've done all of that. So if you have a question about it, great, bring it up. I'm going to write another problem on the board for us. Let's say I have this 2x plus 3y is equal to 19. And then 3x minus 7y is equal to -6. And just so that we're all doing the same thing, and I want to make sure that we understand how the signs work on this problem, eliminate the x's. Okay, I'm declaring, as the math dictator right here, I'm declaring that we are eliminating the x's. give us all a nudge. I'm not gonna work the problem yet, but I said, let's eliminate the x's. So what did you multiply the top equation by? Okay, so if you multiplied the top equation by 3 and got 6x, if you did a 3, what did you have to do here then? Okay, so if you were opposite though, if you multiplied the top one by -3, and that's fine, then what did you have to multiply the bottom one by? +2. Okay, so you did one of those two things. You got to alternate the signs on this one. Let me give you a little more time to finish up the arithmetic. All right, I'm going to get started. If you're working, keep working. No matter what you've done, whether a +3 or -2 or a -3 +2, or whether you eliminate the y's, we all will end up with the exact same answer. Okay, no one at the end of this problem should have anything different. Okay, there's no other answers. So the top equation becomes 6x and then 9y, and then 3 times 19, I think, is 57. The bottom equation is -6x, and then plus 14y, and then +12. The x's eliminate, that's what I wanted. 9 and 14 is 23y, 57 and 12, 69. And when we divide, we get y is equal to 3. Pick your favorite equation. Just for kicks, I'll use the bottom one this time. And so the y value is 3, so I have 3x minus 7 times 3 is equal to -6. 3x, that's -21. And then add the 21, and then we'll divide by 3. And at long last, we are at the answer. I think that's 15. Talking and subtracting, I can't do that. There we go. X is 5, y is 3. That's the elimination method. Anybody got a question, comment, concern, conundrum, commotion, any sort of word to express that you're uncomfortable?
I used the top part for the second section, is that okay?
Yep, you should have gotten 5. Yep, definitely okay. And I love that you mentioned it, so thank you for doing that. Okay, so here's another one. I would like you to solve this one by eliminating. Go ahead and eliminate the x's on this one as well, so that we're all doing the same thing. So it's 2x minus y is 3, and then 6x minus 3y is equal to 9. So give you a moment or two to eliminate the x's on that problem. What's the common multiple between 2 and 6? 6. Somebody in here probably used 12. That's totally fine. You'll end up with the same conclusion I did. But this is a nice problem because I don't have to multiply both equations by anything. I can get away with just multiplying one. So what do I have to multiply the top equation by? Yeah, -3, because -3 times 2 will make a -6, and this is already a +6. If you decided that the multiple was 12 because you said 6 times 2 is 12, I totally get the thought process. So you would have multiplied the top one by a 6 or a -6 and the bottom one by 2 or a -2. Okay, so that's totally fine. It's going to work. So just keep going with it. So when I do this, the top equation becomes -6x and then plus 3y and then equal to -9. The bottom equation is this right here. And then the reason I gave this problem is because there's two special situations, and this is one of them. Not only did I end up eliminating x's, but what else happens on the left side of this? Yeah, not any fault of our own, just because of the equation, the y's get eliminated too. So I have nothing on the left-hand side, no x's, no y's, so I just have a big 0. Okay, no, not a 0x, not a 0y, just 0. 0 times anything is always 0. On the other side, the -9 plus 9, that's 0 as well. So I end up with this statement right here. So the question is, what does that mean? Okay, this might happen on your homework. What, somebody said something?
No solution.
Okay, close. That's going to be the next one we do. What did you say? Yes, and that we need to interpret that. You're totally 100% right. So what's going on here? Is this a true statement or a false statement? It's true. It's always true. There's no x's, there's no y's. It's never going to be anything but true. 0 is always equal to 0. What this is called, okay, I'm not super concerned about terminology. I'm not going to quiz you on the terminology, but when you're on My Math Lab, they'll ask you about this. So this right here, this is called an identity. No, it's not. That's the equations. Sorry. Good thing I'm not quizzing you on this is called a dependent system. What this means is basically you have two lines that are the same line. They're just multiples of each other. So when you have a dependent system, what you had was the same line twice. So if we were to graph it, okay, so we're not going to graph it, but if we were going to graph it, we have the same line twice. So what that means is if you have a line and then you graph the other line right on top of it, what that means is they intersect everywhere. They intersect at every point on the line. So to answer your point, because you made a very good one, how do all real numbers seems like what it's going to be, and with a caveat. It's not just all real numbers, it's any point on the line. Okay, so it's not just anything, it's any ordered pair that is on the line. So here's how you write the answer in our book. It's different in the college algebra book. I wish there was more consistency. I'm sorry about that, but this is what you're going to see. In My Math Lab, they're going to give you this. Okay, so we have a set, and this is the set of ordered pairs, x's and y's. Okay, so what we're saying is this is the set of solution points, the x's and y's. Okay, so if you're making a note to yourself, this is the set of solution points. Then you're going to see a little bar. What's true about the solution points? Well, they satisfy this equation right here, 2x minus y equals 3. So what this notation is saying in a weird kind of way is that the solution points to this, the x's and y's that are the answers, are any x and y that satisfy 2x minus y equals 3. Any point on the line is a solution. Okay, so that's what that means. The other special situation, I'm not going to make you go through the labor of solving something new. I'm going to just take those two equations. I'm going to adjust one of them just a little bit. So this is going to be 2x minus y equals 3. I'm going to take the second equation. I'm going to make it 6x minus 3y is equal to 14. Yeah, right on.
So what if you wrote like for the solution set 6x minus 3y is
Okay, so that's a really good question. Thanks for reminding me. I appreciate asking it. As far as me on the test, if I give a problem like this, I have no qualms. Either one. Okay, that's fine. My Math Lab, I believe, wants the reduced one. They want the one that's in the lowest terms. So that's the 2x minus y is 3. Okay. They're the same equation, so it absolutely does not really matter. I think they just do that in My Math Lab because they only have so much memory. That's the only justification I can think. Okay, great question, appreciate it. Okay, so I've kept the top equation the same. The bottom equation I have changed to 6x minus 3y is 14. And so here's what I want to know. Okay, will it always end up being 0 equals 0? Great question. I'm glad you're thinking it. I'm glad you asked it. So I'm going to do the same thing that we just did. This is no different. Not really super interesting once we've seen that. So I have negative 6x plus 3y is equal to negative 9. The bottom equation stays 6x minus 3y is 14. I'll give you a second to get caught up. All of that, that's nothing new that we just did right there. That's why I went through it sort of quickly. Once again, on the left, everything cancels. There's no x's left. There's no y's left. We have 0. But here's what happens on the other side. Here's where the difference is. And this is what I wanted you to see. This time, negative 9 and 14, does that end up being 0? No, it ends up being a number, in this case 5. Okay, so what happens in this situation? I've got 0 equals 5. Is that a true statement?
No.
No, that's false. It's always false. It's never going to be true. Okay, this is called, again, I'm not super concerned about the terminology, but just so you can do your homework, this is called an inconsistent system. It's called an inconsistent system. We're thinking about the picture of an inconsistent system. What we have here is we have two parallel lines. If we were to graph this, if we were to graph both those equations, they would be parallel lines. That's the picture right there. So drawing on a little bit of prior knowledge from the previous unit. When do parallel lines intersect? Never. Okay, so if a solution to a system is when they intersect, and you just told me parallel lines never intersect, what's the solution? What was that? Not 0. I think you mean the right thing, but you're saying the wrong thing. Not 0. It's called the null set or the empty set. Okay, there's no solution to this. And so one of the ways to write the empty set is the null symbol. It's a circle with a toothpick through it. It's not the number 0. I usually write 2 squigglies with nothing in between it. So pick your favorite symbol. Same thing that we saw when we were solving equations. So these are parallel lines. They never intersect. So there's no solution. This is the same line on top of itself. So it means it intersects everywhere on the line. That's why the whole line is the solution. And those are the 2 special situations. And that is the end of solving systems. Woohoo!